Section 2.6, Derivatives and Rates of Change. Tangent lines. The first problem that we're going to take a look at is the tangent line problem. Before getting into this problem, it would probably be best to define a tangent line. A tangent line to the function f of x at the point x equals a is a line that just touches the graph of the function at the point in question and is parallel in some way to the graph at that point. So you can take a look at this graph here below. Now in this graph, the line is tangent at the indicated point because it just touches the graph at that point, and it is also parallel to the graph at that particular point. Now likewise, at the second point shown, the line does just touch the graph at that point, but it is not parallel to the graph at that point, and so it's not a tangent line to the graph at that point. Now at the second point shown, the point where the line isn't a tangent line, we will sometimes call that line a secant line. Now we have used the word parallel, and we should be a little careful with it. In general, we will think of a line in a graph as being parallel at a point if they are both moving in the same direction at that point. So in the first point above, the graph and the line are moving in the same direction, and so we will say they are parallel at that point. At the second point, on the other hand, the line and the graph are not moving in the same direction, so they aren't parallel at that point. Okay, so let's take a look at this graph here. Okay, here we have a curve. So if we have a curve called C, okay, and we have 2 points on this curve. So if a curve C has an equation y equals f of x, and we want to find the tangent line to that curve at the point P, which is an x-coordinate of a and a y-coordinate of f of a, then we'll consider a nearby point Q that has a point x and a y f of x, where x does not equal a, and then compute the slope of the secant line of PQ. So as we can see here that these 2 points go through this curve, and both of those points do not show that there is a parallel point. So therefore we're dealing with a secant line. So if you take a look here, if we wanted to find the slope of this line, we can find the rise over the run. So the change in y over the change in x. Well, the change in y is taking f of x and subtracting f of a, and the change in x is going to be x minus a. So therefore, if we want to find the slope of PQ, it's going to equal f of x minus f of a over x minus a. Now if we take a look at this graph on the right, okay, we have this line PQ. Okay, so this first one here is a secant line, and then it moves closer for another secant line to the point where it then becomes a tangent line on P. So to describe this, we can say then we would let Q, okay, approach P along the curve C by letting x approach A. So if the slope of PQ approaches a number m, then we define the tangent T to be the line through the value of point P with slope m. This amounts to saying that the tangent line is the limiting position of the secant line PQ as Q approaches P. So this comes to our first definition. Definition states that the tangent line to the curve of y equals f of x at the point P of a f of a is the line through P with the following slope. The slope is equal to the limit as x approaches a of f of x minus f of a over x minus a, provided that this limit exists.